Welcome everyone to today's session. Today we are going to start the second portion of numerical measures. In the previous session, we talked about we studied the topic of uh, measure of center or measure of a central tendency. Now we are going towards measure of variation. So what does it mean? So in the previous class we talked about what are so one adjective that we would try to measure. The adjective was center, representative, or ideal, or repeated. So the values which were in the center, which were most representative, which is the ideal, which is repeated, value that can summarize the habit of data. So we were able to understand the rules or the types of methods that we can use to summarize the data in one number that is explaining the habit, what I call habit or most commonly existing value, most centrally placed value, best representative value, ideal value that can sum up what the data is talking about, most repeated number in the data. So that's why I would say it is habit. So we studied this in the previous session. Now we are going to start with the new topic, that is measure of variation. What does it talk about? That if you have a number line and you found out its center, which is the most representative number that is representing this set of data, where this is the lowest value LV and this is highest value, you need to see how the individual data set is scattered around the mean. So if the center here is, most probably most of the numbers will be located here, few of them here. The more you go far away from the center, the number of observations will fall. So this will look like a symmetric shape. So the shape, the width of the shape is determined by the variation. So if we what in simple words, if we have the center value and if we have the data, then we also know that how the data is scattered, and the width of the distribution curve will tell us how the data is variating or how the data is scattered around the center. So this is what we are going to talk today. So in order to measure variation, there are four different ways. There are many more, but we are going to focus on these four ways. First is a way that is called range, and it has another type which is called interquartile range. Second is variance. It talks about how much variation is. Then there is a standard deviation, and there is another type. There are a few more types of standard deviation which are not in the tables in this set, but I will write few names like mean deviation, is this one type, and then we study coefficient of variation. So these are the topics that we are going to study today. So we'll start with first slide. We start with what is variation. So it measures of variation give information about the spread or the variability of the data values. In this example, there are two different data sets which has same center, but one of them has high peak, another has high width. So data which has high width will have high variation. The data which has high peak will have low variation. So this way we describe the variation in the data. So the shape will determine the variation. So the more spread out the data is, the more variation it has. More spread out means that the individual observations can be found very far from the center, or if the height is the peak is high, then individual values are found relatively near to the center. So it means for the green case, the center is a better representative representative as compared to why? Because in the red, the individual observations are very far from the center, but for the green, the individuals are near. So while we compare the quality of or for the reliability of the center, reliability of center as a good summarized value, it needs to make sure that it has small variability. अगर डेटा में वेरिएबिलिटी ज्यादा होगी तो सेंटर की वैल्यू जो हमने पहले निकाल चुके हैं उस पर ट्रस्ट करना उतना ही मुश्किल होगा और हमें उतना ही कॉशियस होने की जरूरत है कि वो सेंटर गलत हो सकता है या रियल लाइफ में रिस्क ज्यादा होगा. So in simple words, if the variation is high and if you rely on the center, there is a high risk that the answer may change and you might face a unexpected benefit or an unexpected loss. But if this variation is low and then you rely on the center, the risk will be low regarding to unexpected returns or unexpected loss. So this is the way we explain the data. Now we'll go towards next slide. Here we'll talk about first topic, that is measure of range. From the word we understand a range is simplest measure of variation. It is the difference between the largest and the smallest observation. So if you have the data where there is one observation equal to 1, second observation is 3, then there are two 5s, 1 7, 3 9s, 1 10, 2 12s, 1 13 and 14. So the highest number is 14 and the lowest number is 1. So range of the data is 13. So this way we measure how spread the data is. How spread. So the range is 13. The sensitivity of the range is that we'll talk about in the next slide. First of all, it is sensitive to the units of the data. So if the data is in simple, so if data is between 0 and 100, its range will be different. But if the data is millions, then the lowest number and the difference between lowest and highest will be very high. So it means the range, because is this data is sensitive to the values of the data. So this is not comparable across different data sets. So if you have similar data of different banks, then you can compare the range. If this data is some other data with different units, then you cannot compare the range, that this data has a more range, so it is more spread, or this data has smaller range, it is less spread. So this should be taken care of while discussing range. Now for the case of range, another disadvantage of the range is that it ignores the way the data is distributed. It does not know the distribution of the data. It only cares about highest value minus lowest value. What is happening in between, it doesn't matter. For example, in this data, the range is 5. Highest value minus lowest value. In this data, range is also 5. But in this case, data is differently placed, and in this case, data is differently placed. So range does not care about how the data is distributed, or in other words, how the data is changing, or how the frequency of individual observation is changing. It only cares about what is the highest value and what is the lowest value. Second problem is that it is sensitive to outliers. For example, in this data, the highest value is 5 and lowest is 1. All other observations are like this, so it ranges 4. But in this data, only highest value is changed. All other values are similar. It range is changed. So it is very sensitive to outliers. So this is another way that we can check if there is an outlier in the data. You can draw a box plot, and if the box plot has more space on the right hand side, it means the highest value might be an outlier, and the range will be very big. So this way, and the third problem I already discussed, that it is not comparable across different data sets which has different units. So this is the topic about range. Let's see the next slide. So next topic is interquartile range. Interquartile range is a type of a range, and it is used to solve the problem of outliers. So that's why it is invented or innovated. So it the method that they use is that rather than subtracting highest value minus lowest value, it says that subtract quartile three ways, quartile one. So these values are not sensitive to outliers. So that's why we can use interquartile range. We were studying interquartile range, and I gave you example that interquartile range is different from range, such that for the case of range we were subtracting highest value minus lowest value, but in interquartile range we use quartile 3 minus quartile 1. So what is the advantage of that? That since quartile 3 and quartile 1 are in between the data, for example, if this is the data range, this is the lowest value and this is highest value, so this might be Q1 and this is Q3. So if you subtract them, it will become IQR. So since these values do not have any link with outliers, so this value will not change even if data has outliers. Let's move forward. So it is giving us an example that if you have a data, if you create a box plot, the lowest value will be here, highest value will be here, 20% data, 25% data will be in between, minimum, which is also known as Q0 to Q1, and there will be 25% data from Q1 to Q2, which is also called median, and which will always also be equal to mean value if data is symmetric. And then Q3, from Q2 to Q3 there is 25% data, and there is maximum minus Q3, so it's 25%. Q maximum is also called Q4. In terms of percentiles, I will label this diagram. This will be P0, P25, P50, P75, and P100. So these are percentile names, and these values are answered to each location and symbol or location name from the data. And the answer came out is that interquartile range is 27. So this number has one advantage, that it is not sensitive to outliers, and it also gives us some indication that how the data is scattered. Next topic is variance. Variance is the average of squared deviation values from the mean value. So what does it say? That if you subtract each observation with its mean value and then square it, then add all the numbers and divide it with n minus 1 to calculate average, it will become s square if it is a sample. For population, it will become sigma square. So this is the variance. So I will show you one little example and then we'll see it in detail in the next slide. Suppose you have a data of x and then you calculate x bar. So what you have to do next is calculate x minus x bar. Okay, and you calculate this. By definition, sum of x minus x bar is 0. If you are calculating x minus x bar and if its answer is not 0, it means the mean was wrongly calculated. This is the property of the mean, that if you subtract it from the data and calculate its sum, it should be 0. So this is a law, or this is a rule, or this is the property of a good mean value. Even if data has outliers or not, mean value has a property that when you subtract it with the individual observation, it has 0 answer. So when then you square it, x minus x bar whole square. Okay, and if you sum it, we call it sum squared deviations. It will not be 0 because all the negative and positive values are converted into positive while calculating square. So it will have some number and it has a name. If you sum it, it has a name that sum square deviations. So sum square deviation formula is this, the numerator, summation x minus x bar whole square. And if you have this answer divided with n minus 1, it will become s square. So this is the formula for standard deviation in the sample. In the population, we divide it by n. So the question arises, why n minus 1 in sample and why n in population? So the logic behind is that the s square is not unbiased estimator. So we need to make it unbiased. So we do this correction term. So in this video, this is the shortest possible logic that I can give why we use n minus 1 here and why n here. But if you want to understand in detail, then you need to study applied statistics or have a look at the applied statistics book. It will give you examples why we use n minus 1. So for now, this logic is enough to explain why we use n minus 1. So whenever you are asked to calculate standard deviation, you need to have a look at the question if they are giving you data of sample or population. If the data is population, you have to divide it with n. If the data is sample, you have to divide it with n minus 1. I will go to next slide and it will show you a few examples. Then there is standard deviation. The difference between standard deviation and variance is that it has a square root, and if you remove the square root, it will become variance. So most commonly used measure of variance, it shows the variation about the mean value. It has same units as the original data. So the formula is almost similar. If you go with the variance, it is s square, and if you take under root, it will become s, and under root will be here too. So this is the formula for standard deviation. So both of these have a similar meaning, but the answer will be double in variance and as compared to standard deviation. But both of them will talk about that how much the data is scattered. So this is an example. Suppose we have 8 observations in a sample data and the mean value is 16. What we will do, we will subtract all of the numbers 10, 12 from the mean value, and I will put the value 10 minus 16, 12 minus 16, 12 minus 4 minus 14 minus 16, so on 24 minus 16, and square them, add them, divided by 8 minus 1 because it's a sample, and square root. So the answer is 4.2426. So this way you calculate the standard deviation. So for this example, what will be the variance? It is if you don't square root it. So 4.2426 multiplied by 4.2426, it will become 17.99. So the s square will be 17.99 and s will be equal to 4.24. So this way we calculate the sample, standard deviation and sample variance. So in the next slide, what is doing it is saying that why standard deviation is important, because it tells shape of data, or in other words, distribution. Or if in the start of the video I talked about the width of the distribution or the spread. So in this video, we have three data sets, and if you note that all of them have same mean value, so it means we found three different examples where the center is same, but the problem is that they have different standard deviations. So in this example, the data is very spread, and in this example it has a high peak, and in this example it has two peaks. So the one thing that I talked earlier. So now we have three data sets. We know the standard deviation value 3.3, 0.9, 4.5. So as I discussed earlier, if the standard deviation is low, it will represent that the data has a mean value which is more realistic. So let's have a look. So in this data, the mean value is 15.5, and you notice that there are few values that are nearer to mean value, but none of them is equal to 15.5. So it is okay. In this example, most of the data is located very near to the center. So this is better than above. And in this example, none of the data is located near. So it means whenever S increases, the spread increases, or in other words, the trust on X bar as a good representative decreases. Okay, so this is the way we explain. So in other words, when you have a data, you will first of all calculate the center using mean or median or mod to tell what is the habit of the data. But you need to also check the standard deviation to have a look how reliable, how consistent, how representative the habit of the data is. Otherwise, it is not trustworthy. So next we go to the next slide, and in this slide it is giving us the next indicator. This is called coefficient of variation. The first of all, before talking about coefficient of variation, I will tell you the problem that we might face, the problem that coefficient of variance tends to solve. Suppose you have a data of share price, and you are looking to invest into the data, and you have two indicators of the data available. You have the mean value and you have the standard deviation of the data available. So as per our observations, we know that whenever X bar will increase, we will be happy that the share price is going up. We will earn more profits out of it when we sell at a higher price, or it is an indicator that we should buy it now so that we can sell at higher price later on. So increase in X bar is a indicator that is in favor of our decision. On other side, the other indicator is the standard deviation. But if the standard deviation increases, it is an indicator that the risk will increase. So if you invest it in the share price, what will happen? It is highly likely that you might end up with a loss. So the problem is that you need to compare these two while you are making the decision. So as a human decision maker, let's suppose that you see a share price where both of these things are increasing. Both, that the share price of, let's say, Mizan Bank Limited has a shares in the market, and if you see the patterns of last 1 year, you notice that X bar is increasing and S standard deviation is also increasing. So as a human, one indicator is telling different thing and other is telling the opposite. So uh, by looking at these two indicators, for us it will be difficult to conclude what is an outcome. We will not be able to tell that if this benefit indicator is telling right or the cost indicator telling us right. So in this case, whenever you have two indicators, it is these are most common indicators. So it's highly likely that you will have these two indicators every time. So the problem will arise when they will give you conflicting indicators. So in that case, we use the coefficient of variation method. There are other methods, but this is the first of them. So coefficient of variance method. So this measures the relative variation. So it checks how much Sx has increased as compared to X bar. Okay, so its units are percentage. It shows the variation in the data as compared to the mean value of the data. So in other words, it means if the variation is increasing more faster than the mean, then the CV value will be more than 100 because it is multiplied by 100. If the mean value is increasing faster than the variation, then the CV value will be less than 100. So it compares two or more data sets. So this is first advantage that I discussed here. Second advantage is that if you have two different share prices, let's say firm 1 and firm 2, there are two different shares in the market. This is X bar 1 and SX1 for the first firm. This is X bar 2 and SX2 for the second firm. Most probably, if X bar 1 is greater than X bar 2 and SX1 is less than SX2, we will say that F share price F1 is better than F2. But the conflicting situation will come if X bar 1 is more better than X bar 2, but SX1 is also higher than SX2. So first indicator is talking that we should invest in F1, but the second indicator is talking that we should invest in F2. So this is also a conflicting situation. So in this case, what we'll do, we'll calculate the coefficient of variation. So the formula is variation standard deviation divided by the mean value, or sample standard deviation divided by sample mean value. So it will give us, multiply by 100, it will give us the answer for coefficient of variance. So in both share prices, we will calculate this CV. Okay, and the CV which is smaller is relatively less variating or less risky. So this way we can calculate relative variation and then we can compare. So I talked about the two advantages or two purpose of this method. Let's go to the next slide. So it has given us an example. Here we can see that there are two stocks. Average price of stock A is 50 and average price of stock B is 100. Based upon this indicator, stock B is more valued or more higher value, and the standard deviations are same. Both have equal variation. So the first indicator talks about that it should stock B is better, but the second indicator talks about that they are equally better. So we need to confirm which stock is better. So what we will do, that we will calculate the coefficient of variance. If you see in the top, the answer is 10% and the bottom answer is 5%. So the both stocks have same standard deviation, but B stock is less variable relative to its price. So it means that it is less risky as compared to stock A, even though the variance are same. So this is another purpose of using coefficient of variance. You can compare two different things. where either means are same or standard deviations are same. You can compare which one is relatively better. So the let's move forward and have a look. Next topic. So this is an example for coefficient of variance. Let's suppose you have two players, Shahid Afridi and Misbah Haq, and their scores are shown below. This question has two sub questions, but I will only focus on the question which is relative to coefficient of variance. So we have two data sets. We need to talk about which one is more consistent. Which player is more consistent. So in order to check for consistency, we will consistency includes two things. First is habit, and second is deviation from habit. If the habit is high and the deviation is low, it is consistent. If the habit is low and deviation is high, it is inconsistent. So what we'll do for Shahid Afridi, we will calculate the X bar and its standard deviation, and we'll calculate the CV, that will be equal to SA over X bar into 100%. Similarly, we'll calculate for Misbah Haq. So have a look that even though Shahid Afridi has done few high scoring matches, but he also has a 0 in it. But Misbah Haq, even though he does not have very high scoring matches, but his lowest score is also high enough. So it is likely that the CV value of Misbah Haq will be smaller than the CV value of Shahid Afridi. It means Misbah Haq is more consistent. Even though its habit is not very high, but he is very strictly connected or very near to what his habit is. So this is the application of calculating coefficient of variance. So let's move forward. We have talked about the example of CV, and in the next slide, it's empirical rule. So before talking to empirical rule, I will add it here that why we use X bar and ST. So we need to go back to the start of statistics. We talked about that humans like certainty over uncertainty. So they try to predict the future, and while they're predicting, they try to find the most representative answer that they will face in the future. So if the X bar is big, they will be happy that there will be better situation in the future. But if SD is big, they will see that there is more uncertainty in the future. So this is an indicator of uncertainty, and this is the indicator of returns. So in the finance, we compare the returns with the uncertainty or certainty to find out the relative returns. So this is the way the statistics play a role in explaining in our decision making. Next, the topic that we are studying is next topic after the measure of dispersion. Okay, so in this topic we will talk about the empirical rule. The empirical rule is the formula that helps us to guess guess the chances of occurrence of observation within certain range. Chances of occurrence of X within a certain range. So I will read this and then we'll go towards examples. So if the data is distributed in the bell shape, in other words, it is called symmetric or normal, or normal. So if the data is normal or symmetric, then it's also called bell shape. Then what we can see is that if we have a X bar given and standard deviation given, if we calculate this number, that X minus standard deviation, let's suppose the X bar is 5 and standard deviation is 2, then this range is 3 comma 7. Mu minus derivation 5 minus 2 3 and 5 plus 2 7. So this says that if you know that data is symmetric, then if you calculate this range, then you can guess that 68% of the data will be in between. In other words, it is saying that if you have this data set and this is its mean value and its spread is S value, and if you use this and calculate mu minus S and mu plus S, this range has a 68% chance that a 68% chance that the new value the data will be in between. So let's suppose you have 100 observations, though then if you calculate this range, 68% of the values or 68% of the data will be in between. Okay, so let's give you one example. Let's suppose you have a data of non-performing loans, and you calculate its mean value. Let's say you have data of 100 observations, 100 cases of non-performing loans or default cases with declared bankrupt. So the default cases, let's suppose there are some values, and you have 100 observations, each has different amount of um, the bank the default loan size. So if you calculate the mean value and calculate the standard deviation S, and if you, or if it is a population, then it is mu and sigma. If you calculate x minus S and x plus S, it will give you a lower limit and upper limit, a range, a point. So this will be the lower limit and this will be the upper limit. Assuming the data is well shaped, you can guess, or you can safely say that between this amount and this amount, 68% of my non-performing loans cases exist. The biggest non-performing amount and lowest non-performing amount. So this way you can calculate. Similarly, you can also say, let's suppose you are talking about the Ijara file approval, Ijara case approval times. How much time taken by the central head office to approve a case of Ijara. So if you have like sold like 100 cars and you have times written how much days it took to approve the case, let's say 1 day, 5 days, 7 days, 2 days. So there's a data of 100 observations. Then you calculate the mean and standard deviation and you calculate the range. The answer comes between 2 to 7. So you can say to the next customer that I am confident that there are 68% chances that your case will be solved between 7 to 2 days. So this is the way we can use this empirical rule to give a guess of the next value or to the next client. So we use empirical rule to create some sense of estimated value or some guess that we can quote it somewhere to our next client or to our boss, to our team, so that they know that this is the range, and we should so that we can have a guess that we already have a guess of the ideal center. We already have a guess of how data is spread. We also now have a guess of where the majority, within which range the majority, 68% of the data exists. So in other words, that out of 168 times you will observe that your data is in between this range. Let's see next slide. In the next slide, he says that if you calculate x plus 2 standard deviation, then the range that you will get, the data will be 95% in between. So it means if you calculate this range and you can quote to the Ijara customer that I am confident 95% that your case will be solved between this low limit day and this higher limit day. Or if you use 3 standard deviation, you can say I am confident 99.7% that your case will be solved between this low limit day and this high limit day. So this is used for this estimation. So this process is also used in many production processes where they want to guess the rejection rate of their products or the efficiency of their machines, so that they know what is the potential loss. So for example, there is one machine that is printing cloth, and the customer, the producer has given us that we are confident that uh, uh, within the quality of the thread in the cloth will be between this and this 97.9% of the time, and if it is below it, it will be rejected, and if it is above it, it is too good and it will be a loss for the company if you sell it at the same price. So the companies tend to find these limits. So moving on from empirical rule, next we have is slide number 43 is a practical example. So I will explain them here and then you can try to solve other examples that will be shown in the next slides. Suppose you want to see what is the overall performance of the students of UMT. Since there are too many students, so we can too many students, we cannot look at the data and tell what is happening. So that's why we need help of statistics. So we make a sample and get the data out of the GPA. So from the many students, we collect a sample. So we got the CGPA from 40 students and its mean value is 3.1. So this is the central tendency of these 40 students in terms of their performance. And this standard deviation is 0.56. So we have a center and a variation of our data. Now we want to know what is the range of CGPA in which a certain majority of students normally exist. Why I made it capital? Because we are assuming the data is normal. Okay, so the data normality should be ensured first so that we can apply this method. So if we calculate this mu plus minus 1 sigma, empirical system says that 68% of students will have the GPA in between this range. So we calculated the answer is 2.54 comma 3.66. So according to empirical rule that if the data is normal in the population, 68% of students will have the GPA between this range if you check them out. If you calculate mu plus 2 sigma, 95% of students will have between 1.98 and 4.22. Similarly, you can get the value of 99.7% range if you use 3% sigma. So you can calculate it yourself and see what is the range here. So this way you can have a few guesses of how the data is scattered or a percentage in terms of percentages. So you will see the severity of the data. If this percentage is the range is very wide, then the data is scattered. If the range is narrow, then there is high chances that you will find that value. Now we'll go towards next slide. So next is Chebyshev theorem. Chebyshev theorem is a theorem that does not worry about the distribution of the data. So you don't have to worry if the data is normal or not. He says that at least 1 minus 1 over k square values will fall between k standard deviation of the data. So he means that if the data has, if we calculate 2 standard deviation where 2 is equal to k, then the formula is 1 over 1 minus 2 square, 75%. So when the k is 2. So he's saying that if the data, even if it is not distributed, if you calculate mu plus minus 2 sigma According to Chebyshev theorem, 75% of the observation will be lying in between. The problem with this method is that you cannot calculate at one standard deviation. So its answer will be 0. So it has this limitation that it will not be used for one standard deviation. Other advantage of this method is that you can calculate for 4, 5, 6 and so on, because in the empirical theorem I didn't talk about above 3. In the books you will find more than 3, but the problem with empirical theorem is that it does not talk about in between numbers. So if I want to calculate the range for 2.5 standard deviation or 3.1 standard deviation, you can use the Chebyshev theorem to get the answer. So this is an advantage of this method up till the topics that we have discussed. So this is an example. Consider the same data of CGPA 40, students whose mean value is 3.1 and standard deviation is 0.56. We want to know what is the range of 1.5 standard deviation and how much percent student will occur. So the advantage is that now we can calculate 1.5 and we don't have to worry about the data is normal or not. So the range is 3.1 minus 0.1.56, 1.5 into 0.56, 3.1 plus 1.5 into 0.56. So it is 2.6 and 3.94. So this is the range in between how many students will occur? 56%. So this should not be here. It should be multiplied by 100 then percentage. So 56% of the observations. So this is the way you can estimate your success rate or your application completion rate. For example, you are a manager that who is managing the customer satisfaction of in your branch. Let's see that if Mizan Bank is measuring the time taken by the branch to solve the query of the customers who is standing in the queue. So they calculate the times taken by the customers in the queue. So you calculate the range in between 90% of the cases are solved, and then that range can be presented in the reports that from 1 minute to 5 minutes 90% of the customers are sorted, their issues are cleared in our branch. So this is our quick response rate. So this is the way you can calculate some statistics that you can show it to your clients or your owners or board of directors to get something to help them create a decision, even if it is against you, but it will help you to get a decision out of them. And if you then plan the statistics correctly and if your performance is good, you might end up getting favorable decisions out of them, because rather than giving them the data of 40 numbers, you gave them three things. First, their center. Second, their standard deviation. Third, a certain range in between majority of the students. Okay, so this is what will help you to get a decision out of them. The next slide will see the example. A population has a mean of 3,000 and the standard deviation is 200. Find the proportion of population whose income fall between this. So if you have a range and you need to find out how much population that falls in between, what you can do is you can find the value of k. So how we can find? We already know that mu plus k sigma will be equal to the highest limit, upper limit, or you can call it QL, upper limit. So upper limit is given, I used it. So 3000 plus k into 200 is equal to 3400. So k is 2. So using that Chebyshev formula, I found out that 75% of my data will fall between this range, which has a mean value of 3000 and standard deviation of 200. So this is another application that if your line manager or a boss or your board of director tries to ask you that tell me between 3 to 7 days how many of your ijara cases are solved. So for that the mean value should be in the middle. So if you have said in your presentation that it takes about on average 5 days to solve my ijara case, so the manager will ask what will happen if we check between 3 to 7? You will say the k is 2. You will say 75% of my cases are solved between this range. So this will help you to present your case better if this number is if the number is high enough, if the variation is low. The next slide, this is another example. So this is for you as an activity. So for the upper and lower limit is given, you need to find the k and tell what is the percentage of the data, percentage of faculty who has the income between this range. Okay. Next, there's another the difference between empirical and Chebyshev theorem. Empirical theorem is always used when data is normally distributed. Chebyshev theorem is used when we don't know if it is normal or not, but the limit is that we cannot calculate it for 1. And for normally distributed means data is symmetric. So this is the difference between two methods. In real life, mostly data is not normal, especially when it talks about the people. So we use the Chebyshev method. Next, we go towards the next method, and this is about standardized values of the data. So standardized value data means that it is the way to give a new number to the data so that the new number can be compared. So I will give you an example. This is a short topic and I think we can complete it quickly. So the standardized data value refers to a number in terms of standard deviation. So it will give you a new number and tells about how far it is from mean. So refers to the number of standard deviations, a value from the mean. Let's say I will say that z value is 1. It's a standardized value. So it means that for x value for which I calculate the z, this x number, xi observation is 1 standard deviation away from x bar. Away in terms of right hand side, it is bigger. If the z is -1, it is 1 standard deviation smaller from mean. So standardized values are sometimes referred to as z-scores. That's why I use z. It is used to compare a new value of the data of with the sample. So that purpose of this process is that if you have two data sets, if you're comparing data as it is, you can use the CV method. But if you have two data sets and you have two new values for each, so then you need to compare the new values from the data and with the other data. Then you can use the z-score method, that how the new value is as compared to the data and as compared to the other data. So let's see an example. Hope you will understand from that. So the formula is x minus mu over standard deviation. X minus mean over standard deviation, and we already know what does it mean. And in the next slide, we'll go for the sample x minus x bar over standard deviation. Let's see an example. Let's suppose we have two players, Shahid Afridi and Misbah Haq. We have last 5 matches scores of them, but Afridi has scored 45 in the 6th match and Misbah Haq has scored 50 in the 6th match. We need to check which player has improved. So what does it mean? That there is an x bar value here and x bar value here, and there is new x value, x6 value. Let's say x6 and x6 here. So we want to see that if x6 of Shahid Afridi is higher than x6 of Misbah Haq in terms of their relative performance. So we can use the z-score method. Let's see if we have an example here. So okay, so these are examples that you can do later on. And then the other slides are talking about how to see the descriptive stats in the Excel. So I will solve this example here for your learning, and after that this session will be concluded. So I will open this. So for our helping, what I will do, I will try to move this table on one side, try to make some space so that you can have some space. Let's suppose the average of Shahid Afridi data is Let's calculate the average. I will open a calculator on my side. Okay, so I will solve it here. So 75 plus 0 plus 35 plus 85 plus 20. It is 205. So the sum of Shahid Afridi is sigma x is 215, and I will calculate its mean. So the mean value will be it's divided by 5. So answer will become 43. So x bar of Shahid Afridi is 43. Now we'll calculate this for Misbah Haq. That is 20 plus 40 plus 60 plus 55 plus 60. So it's 235. 235, and its average is, I will divide it with 5. It is 47. So the average of Misbah Haq is 47. It is higher. Now I will calculate the standard deviation. For that, what I will do, I will use Excel to solve it quickly. So I will show you how to calculate the mean and standard deviation in Excel. So I will return Shahid Afridi data. So mean value formula is average, and I will highlight the numbers. So it's average. So I will say X bar and SD. So I know that this is sample data. So I will say STD dot STDEV dot S for sample, and bracket open. If it is a population, I will say dot P. So its standard deviation is this. For Misbah Haq, it is 20, 40, 60, 55, 60. I will extend this formula from here to here. So this is my mean, and this is my standard deviation. So he says that the new number is x is 45, and this is 50. We need to look at which player has improved more as compared to their past track record. So this is their past track record, and this is the latest match. So what we'll do is we'll calculate the z value. Z value is bracket open x minus mean value divided by standard deviation value. Divided by standard deviation, enter. Similarly, what I will do, I will correct it here. So you have two standard deviation values for both players. First of all, I will interpret it. So 0.19 means that Misbah Haq next match performance is 0.19 standard deviation higher than its X bar, and means he has improved 0.19 standard deviation as compared to his average performance and his dispersion. And for Shahid Afridi, it is 0.06 standard deviation higher as compared to his mean value and his dispersion. So it is logically here that we can see that as compared to the data given. So I will talk about what are the assumptions behind this. Based upon the given data and his average performance and his dispersion and the next match outcome, he has improved this much, Misbah Haq, MH. And based upon the data given, his average performance and standard deviation and his next match performance, Shahid Afridi has improved this much. So z-score is helping us to understand who has improved more. So based upon this result, we found out that Misbah Haq has improved more as compared to Shahid Afridi. So this is the advantage of using z-score in statistics. So we have this example. I will give you a hint so that you can try it at home. In this example, an automobile salesman made a profit of $245 on a subcompact model. This one car, he has made this much profit. Okay, so this is the new X value, and for this car, and the average profit of this car is this much. So he says that X bar is 200 for subcompact model SC, and the profit that he made X, it is simple X, SC is 245. So he says that out of all cars that he sells, he averages $200 profit, but the last car he sold, he got $245 profit. His standard deviation is 50, so SSC is 50, subcompact model. Later on the same day, he made profit of $620 on a luxury model where the average profit is 500 and standard deviation is 50. So he has already given you X bar, two things and two S's and two X values. So what you have to do is calculate two Z values, and for which of these two models the salesman's profit is relatively higher. So what is the answer? The Z value which is bigger will give you the answer. And why we need to calculate the Z value? The purpose behind the Z value is that both car has different bases. Their mean value is different and their standard deviation is different. So if their mean and standard deviation were same, we didn't require Z value. We can just say which one is bigger, we will have more profit. But if the mean and the standard deviation is different, then they are two different data sets, two different characteristics. So if we compare them with a new number, we need to find the common ground. For that we use Z score. That checks how good the new number is as compared to their data set. So the number, its units are standard deviation. So the bigger is more standard deviation. So positive is that it is beyond the mean and negative it is below. Similarly, I will tell you about the last question. In the 5 tests, one student averages 63.9 out of 100. His standard deviation is 3.65. Other student averages 78 out of 100 and his standard deviation is 5.6. Which student is more consistent? Since there is no extra value given, so there is no need to calculate Z-score. You can solve it using CV. But if I give you a new number, let's say there's a 6th test and first student got let's say 70 marks and second student got let's say 82 marks. So you can calculate which one has improved more, and for that you have to use Z-score. Okay, so I think the concepts are clear for the case of measure of dispersion and then relative dispersion and then some tools that can be used in decision making. So if you have any questions, you can ask now.